National Electrical Code Article 250.122 Code addresses the specific situation where grounding conductor within a service entrance cable or conduit containing service conductors can be sized smaller than the ungrounded current carrying conductors. It's important to understand the general rules for grounding conductor sizing before delving into this exception. Generally, the size of the equipment grounding conductor is based on the size of the overcurrent protective device protecting the circuit. Table 250.122 provides guidance on selecting the appropriate grounding conductor size based on the rating of the circuit's overcurrent protection. This table outlines the minimum size requirements for grounding conductors, ensuring that they can safely carry fault current back to the source. However, Article 250.122 Code provides a specific allowance for reducing the size of the grounding conductor in service applications. This exception recognizes the unique characteristics of service conductors and the specific grounding requirements associated with them. The exception states that for service conductors, the grounding conductor can be sized no smaller than the sizes listed in Table 250.102 Code. Table 250.102 Code is used for sizing the grounded conductor for a grounded system, where the grounded conductor is used for grounding the service equipment. This table allows for a reduced size grounded conductor based on the size of the ungrounded service conductors. The allowance to use Table 250.102 Code is permitted when the service entrance conductors are parallel to multiple raceways or cables. This exception is applicable to service entrance conductors only. Outside of service entrance conductors, the normal grounding conductor sizing rules found in Table 250.122 apply, as discussed above. One must carefully examine the installation to determine if the conductors are service entrance conductors or feeder conductors. Service conductors start at the serving utilities connection point and terminate at the service disconnecting means. Feeder conductors originate at the service disconnecting means and run to a distribution panel or a subpanel. The grounding conductor is still sized based on the ungrounded conductors per Table 250.102 Code. The grounding conductor is required to be installed in the same raceway or cable as the ungrounded conductors. The grounding conductor must be copper, aluminum, or copper-clad aluminum. The grounding conductor must be continuous. Splices are not permitted. The grounding conductor must be connected to the service equipment enclosure and to the grounding electrode system. The grounding electrode system includes any electrodes that are present, such as metal underground water pipe, metal frame of building or structure, concrete encased electrode, ground ring or rod, and pipe electrodes. The grounding electrode conductor is used to connect the service equipment enclosure to the grounding electrode system. Grounding electrode conductor sizing can be found in Table 250.66. The size of the grounding electrode conductor is based on the size of the ungrounded service entrance conductors. Some key considerations for applying this exception: firstly, it only applies to service conductors, meaning the conductors between the serving utility and the service disconnecting means. Secondly, the reduced size is permitted but not required. An electrician can always choose to install a grounding conductor that is the same size as the ungrounded conductors or larger, if desired. Thirdly, the grounding conductor must still be adequately sized to handle the available fault current. A qualified electrical engineer should perform a fault current study to ensure that the grounding conductor is sized appropriately. Fourthly, local amendments to the NEC may further restrict or modify this exception. It's important to consult the local electrical code to ensure compliance. Fifthly, proper documentation is essential. The electrical inspector will likely want to see documentation verifying that the grounding conductor size is compliant with the code. The documentation should include calculations showing how the grounding conductor size was determined. Sixthly, even with the reduced size, the grounding conductor must be large enough to provide a low impedance path for fault current. A high impedance grounding path can result in elevated touch potential and equipment damage. Seventhly, the exception doesn't eliminate the requirement for a grounding electrode system. The grounding electrode system must still be installed in accordance with NEC Article 250.50. Eighthly, the grounding conductor must be properly identified. Green insulation or green with yellow stripe is required for grounding conductors size 6 American wire gauge or smaller. Grounding conductors larger than 6 American wire gauge can be identified by other means such as tagging. Ninthly, when multiple services are installed in a building, each service must have its own grounding electrode system. The grounding electrode systems must be bonded together. Tenthly, the overcurrent protection for the service conductors must be sized appropriately. The overcurrent protection should protect the conductors from overload and short-circuit conditions. When applying the exception in Article 250.122 Cron, it's important to consider the overall safety and reliability of the electrical system. The reduced grounding conductor size may be acceptable from a code compliance perspective, but it's important to ensure that the system will operate safely under fault conditions. In summary, Article 250.122 Cron of the National Electrical Code provides a specific exception allowing for reduced grounding conductor sizes for service conductors. This exception is subject to certain conditions and limitations, and it's important to understand the requirements of the code and any local amendments before applying it. Always consult with a qualified electrician or electrical engineer to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. For example, if a service consists of 500 kc mil copper conductors, Table 250.102 Cron would allow for a 1/0 copper grounding electrode conductor. Without the exception, Table 250.122 would require a 3/0 copper grounding electrode conductor. The 1/0 copper grounding electrode conductor would be permitted because it is service entrance conductors. Consider another example. Service conductors are 3/0 American wire gauge copper. The ungrounded conductors are installed in a conduit. Table 250.122 would require a number 8 American wire gauge copper grounding conductor. However, because the ungrounded conductors are service entrance conductors, Table 250.102 Cron permits a number 8 American wire gauge copper grounding conductor to be used. In another situation, service conductors are 250 kc mil aluminum. Table 250.122 would require a number 6 American wire gauge copper grounding conductor. Table 250.102 Cron would permit a number 8 American wire gauge copper grounding conductor to be used. The number 8 American wire gauge copper grounding conductor would be permitted because it is service entrance conductors. The importance of proper grounding cannot be overstated. A properly grounded electrical system is essential for safety and reliability. Grounding provides a low impedance path for fault current, which helps to protect people and equipment from electrical shock and damage. Grounding also helps to reduce electrical noise and interference, which can improve the performance of sensitive electronic equipment. The NEC provides comprehensive requirements for grounding electrical systems, and it's important to follow these requirements carefully. Failure to properly ground an electrical system can have serious consequences, including electrical shock, fire, and equipment damage. When working with electrical systems, always follow safe work practices and use appropriate personal protective equipment. If you are not qualified to work on electrical systems, hire a qualified electrician. The NEC is updated every 3 years, so it's important to stay up to date on the latest requirements. Changes to the code can affect the way electrical systems are designed and installed. The NEC is available from the National Fire Protection Association. Many states and local jurisdictions adopt the NEC as their electrical code. In addition to the NEC, there may be other applicable codes and standards that must be followed. It's important to consult with local authorities to determine the specific requirements for your area. Electrical inspections are typically required for new electrical installations and for significant modifications to existing installations. The electrical inspector will verify that the electrical system is installed in accordance with the code. It's important to schedule an electrical inspection before energizing a new or modified electrical system. The electrical inspector can identify any code violations and ensure that the system is safe to operate. Electrical safety is everyone's responsibility. By following safe work practices and complying with the electrical code, we can help to prevent electrical accidents and injuries.